Hi friends, hope you are doing well. I'm Dr. Ganguly. Welcome to my channel. Today I'm going to talk about how you can use neural networks to boost your research. And very often it happens that if you are a PhD student, you are a research scientist, or you are a professor, your research gets stuck after some time. You keep getting harsh reviews that your papers lack novelty and so on. And you are looking some ideas as to how to make your research more current, more timely, more appealing to the readers at large. Remember that journals are actually published not for the authors of the papers but for the readers. So this is something many scientists often forget, that they should keep in mind as to what is the current technology, and they should focus their research in that direction if they are people who actually want to see their paper published. Now, with that background, let us discuss this topic today, and I'm going to discuss two aspects about neural networks which are very important, and then I'm going to give you some application. So let's start with number one issue, and that is that neural networks are essentially good for solving curve fitting problems. And very often you have what are known as so-called forward problems in engineering. So you have problems where you have some kind of functional relationship, y is equal to f of x, where y is some output and x is an input. Typically x is a vector, there are a series of input, and maybe you have one or more output for this problem. Now in many a case you may have data which links these inputs and outputs, and in that case you can train a neural network to learn this data. So many different types of neural networks can be used, but even a feed-forward neural network with backpropagation is going to do a pretty good job here. Now, why would you use neural networks and not some simple curve fit such as polynomial curve fitting? One of the advantages of neural networks is that they are robust to noise in the data. So most of the time data is noisy, it has a lot of uncertainty built in it. It may be random noise, it may be non-Gaussian noise, and so on. In these cases, neural networks tend to learn the underlying relationship between y and x in a better manner. So at the end of your training of the neural network would have learned this particular relationship. Now you can often develop models based on this, and these are known as data-driven models. So in contrast to the physics-based models most of us know, for example the model of a pendulum or something like that which we can see in physics books, database models are actually developed completely from data. So if you have input-output relationships, you can develop these kind of models. These were sometimes known as identified models, but nowadays a lot of people are taking recourse to data-driven models because they often find the physics of the problem is way too complicated to model itself. So you cannot model too many things with partial differential equations. Only for very simple systems you can do such modeling. Now the second aspect has to do with the fact that even if you are somebody who is successful in modeling something with partial differential equations or with some math model, the solution process for these is very time consuming and so on. So what happens is that the solution process is very intense. For example, if you are using computational fluid dynamics in any problem, you may need high performance computing to actually solve these problems. So what happens in that cases is that you can develop what are known as surrogate models, and surrogate models again develop the relationship of the form y is a function of x, and they do it based on inputs from the code or the computer program. So essentially you run the computer program at a large number of data points, you create this input and output relationship based on the simulation or the computer model, and with that you can set up the surrogate model, also known as the meta model, and neural networks can play a very effective role here. You can not only use feed-forward neural networks here, you can also use radial basis function neural networks. So essentially at the end of this neural network training, instead of running your very intense computation code which takes a huge amount of computer time, you can run the neural network. And remember, once the neural network is trained, it can interpolate between all the points and it can give you data very quickly. So a trained neural network is extremely computationally efficient. So this was the second application on surrogate modeling. Now the number two application where neural networks are very useful is in pattern recognition problems. And pattern recognition problem you can think of as a class of engineering or science problems where you have to solve the inverse problem. So now you don't have y equal to fx, Instead, you want to find x is a inverse function of y. So here what happens is that you have the output data and you have to figure out some input. So essentially this problem was classically in the domain of system identification and so on. So for example, you could take measurements from any system and you could actually say what the system is. For example, if you were to take a human body, you could take various measurements such as blood pressure, such as heart rate, such as the temperature and so on, and predict whether the person is sick or not. So this is like an inverse problem or a health monitoring problem or a condition monitoring problem. Now instead of using Kalman filters or particle filters for solving this problem, you can take recourse to neural networks, because it's very difficult often to develop the various matrices which are required in Kalman filtering. For example, to get the covariance matrix and so on, you may not have the measurement statistics of the system. But what the neural network does is that from the input output data, it figures out what is the relationship between y and x, and once you have shown the relationships to the neural network, it essentially learns how to solve this particular inverse problem. So for example, if you are flying an aircraft, from the measurements which are being reported from the aircraft, the neural network can predict whether there is a damage to the system or not. So these are very useful in many kind of actual problems which require you to take care of health and safety of any kind of system. It may be an aircraft, it may be a car, it may be a nuclear power plant, or it could be a submarine, or it could be a person itself, or even a city. So that's something to keep in mind. Now let us look at some applications of neural networks. Now wherever you have a system where you have some kind of model required, whether it is y equals to fx, or you have a system which requires some kind of inverse problem solution, that is x equal to f inverse y, you can use neural networks. And this is actually in a plethora of disciplines. So nowadays you are seeing data-driven models are surging, and often they are able to solve problems which were not amenable to physics-based solutions. So this is something which has been going on. Neural networks are being applied in signal processing, speech processing, in various condition monitoring problems, digital twin, diagnostics problems, and so on. And of course, neural networks are behind what is the ChatGPT type of formulation, the large language models, etc., etc. So one of the things which have been going on in neural networks is of course the concept of deep learning. So what happens here is that instead of using one input layer, one output layer, and one hidden layer or so on, you use many hidden layers. So that is the depth of the neural network. So essentially, when you have a lot of hidden layers in the neural network, you have a deep neural network. And some of the advantages of deep neural network is that they are able to solve various intractable problems in pattern recognition and in forward and inverse problems which were not amenable to solution before. So this has come up in the last few years, that even things such as language modeling, such as self-driving cars, are now something which can be developed with neural networks. And actually, when you hear a lot of things about AI and ML and so on, people are talking of neural networks, because most of the very simple applications which are there in machine learning, they are simply based on decision trees, etc. And those were there for a long time. What gives neural network deep power is the presence of the depth of the network, which can actually solve many problems. So this is something which will certainly help you boost your research, and I hope you will take a deep dive into this topic if you are stuck on some research problem, and you will benefit from this particular video. So I'll end this video now, and I will see you in a video sometime soon. See you then.